Now let's talk about the different fiber types and how they are collectively used in different types of exercises. So each muscle is typically a mixture of fiber types, right? If you look at the biceps, for example, it's not going to have all fast glycolytic or all slow oxidative. It's going to be a blend of different fiber types, but it's going to have a predominance of one or the other, depending on how you're conditioned, the types of activities that you typically do, as well as the location of that specific muscle. So an example here is the postural muscles. These are the muscles of the back, the erector spinae muscles, for example, or the soleus of the calf. These are going to have more slow oxidative fibers just because of their physical location, right? They're usually in positions that we need just to maintain our posture. So these types of muscles are going to have a more predominance of slow oxidative, but that is not to say they don't have some of the other types. Now, in a single motor unit, however, all the muscle fiber types must be the same. So while we can have variability from one motor unit to the next, a motor unit must have all of the same fiber type, whether that be oxidative or glycolytic. And if we recall the recruitment principle, the recruitment of muscle, and we talked about the way that we recruit from small motor units and small fibers first to large motor units and large fibers, just to be more efficient for the body. This will also apply to the way that we recruit with muscle fiber types as well. So we will typically recruit slow oxidative fibers first because they're smaller, they're easier to depolarize, they're attached to smaller units, which typically have smaller motor neurons. So we will recruit the slow oxidative fibers first, then fast oxidative, which is sort of intermediate, and then the larger fibers, which are going to be the fast glycolytic fibers. Okay. And just to kind of compare the types of activities that we would ascribe to these, for slow oxidative, this is going to be walking, jogging, cleaning, as we mentioned earlier. Swimming is another type of activity where you can typically maintain respiration, and so that can be a slow oxidative type of activity. On the other end, for fast glycolytic, sprinting, powerlifting, running, just more intense exercises where it's not possible to maintain respiration in order to match what the muscles are demanding. Okay, let's talk about fatigue here and the reasons why each of these muscle types will fatigue. So let's start with the high intensity exercises and more of the glycolytic fibers. The reason we see fatigue in these types of muscles is typically the buildup of lactate. So that lactate or lactic acid is going to be the reason that we see fatigue in this type of activity and with these types of muscles. Now, these stronger contractions can also compress blood vessels. That can be another reason that we see fatigue. We also see depletion of the neuromuscular um, vesicles. So the vesicles at the neuromuscular junction, which are storing acetylcholine. The more that we have these really strong contractions, which require a lot of these neurotransmitters, the more we can deplete these neurotransmitters at the neuromuscular junction, and that can also contribute to fatigue. And then the other reason here is altered enzyme activity, because when we have buildup of lactate, that creates this acidic environment. And the acidic environment can denature or deactivate the enzymes, the glycolytic enzymes that are needed for anaerobic glycolysis. So that can also contribute to altered enzyme activity and therefore fatigue. And the recovery rate that we typically see with high intensity exercise is usually minutes to hours. So because they have an easier time resulting in fatigue, it's easier to build up lactic acid, easier to deplete um, these neuromuscular junction vesicles. We usually see fatigue happen faster, but also fatigue recover faster as well. Okay, so recovery here can be faster in minutes to hours. Now, comparing that to low intensity exercises, the reason for depletion or fatigue with low intensity exercise is that we just don't have enough glycogen stores. So depletion of glycogen stores, this is why long distance runners usually have lots of glycogen build up and they train their bodies in that way. But if we deplete those glycogen stores, we typically have no sources to tap into for low intensity exercises. And this will take a longer time to recover. Again, if you think about running a marathon, you may run that just fine, but then it may take you a week just to recover and your muscles to get back to full, proper conditioning. So it'll happen slower and longer, but it'll take a longer time to recover as well. And then there's also a psychological component to fatigue as well. When we think about fatigue of muscles, there's usually this psychological component, especially in athletes, we see this, where they will usually have this will to win. And that can sometimes overcome the physical fatigue that we're seeing with muscles. So if any of you in here are athletes, I'm sure you've had to tap into this at some point during a really challenging game or a really challenging event where physically your muscles feel exhausted. Physically, you can feel the signs of fatigue, the burn in your muscles, the buildup, but psychologically, you can sort of overcome that and still push through, and your muscles can still perform to an extent just to kind of get you right to the edge, right? So that psychological component can also override some of the other physical signs of fatigue. Let's think about what fatigue looks like, just illustrating fatigue. So fatigue is where we stimulate the muscle. So here's a normal muscle contraction. This is isometric. And so an action potential stimulates the muscle fiber, and then we see the contraction, right? And that is sustained. That is pretty much the same throughout time. Now, when we look at what happens with fatigue, we stimulate that muscle, and then there becomes a time where the same rate of stimulation and the same sort of frequency, the time in between is the same, but the amount of force or the power of the contraction depletes with time until it gets to zero. So this is what fatigue looks like. So the muscle is no longer able to maintain its same output, its same forceful contraction, even though the rate of stimulation is the same and is happening at the same frequency. Another demonstration of fatigue is after tetanus. So tetanus we describe as being this fused contraction where there's absolutely no relaxation in between. So because of the increased frequency of action potentials here, we have this tetanic contraction, and then we see fatigue. And fatigue means that the muscle eventually gives out, for one. Fatigue also means that after a period of rest, the muscle can no longer live up to that same contraction. So even after a period of rest, the contraction that happens is still going to be shorter and not able to be sustained for as long. Okay, so fatigue can mean a decrease in immediate function, but it can also mean decreased function even after a period of rest. Now let's talk about some of the long-term responses to muscles based upon different types of exercise. And this is where, again, athletes, I'm sure, are well aware of this type of conditioning that can be done to your body and to your muscles and can use that to their advantage. So if you do lots of aerobic exercises, so walking, jogging, swimming, you're going to condition your muscles to be more reliant on oxidative phosphorylation. So over time, more long term, your muscles will have an increased oxidative capacity. They are going to still have some fast glycolytic fibers, but some of those can be converted to become fast oxidative. And so fast oxidative is still fast, but it's just more reliant on oxidative phosphorylation. So you're going to condition or convert some of those fast glycolytic to become fast oxidative. And I do want to just point out while I'm on this here, sort of a short tangent, but we can convert fast glycolytic to become fast oxidative. You can convert a muscle to become oxidative or glycolytic. You cannot convert a fast muscle to become slow. So the fast versus slow, that is permanent. But the glycolytic versus oxidative, you can condition your muscles to be more reliant on one versus the other. Okay. So that is just one conditioning that we'll see in terms of the muscle fiber type. We can also increase the size and number of mitochondria just by nature of being more reliant on oxygen and diffusion of oxygen. We can decrease the fiber diameter, again, to have more of an ability to diffuse oxygen across, and then we can increase the blood supply or capillaries surrounding the muscle fibers. All right. So these are the types of changes that happen in your muscles, in your body when you do more aerobic exercises. And this is typically why physicians encourage their patients or, just in general to do more aerobic exercises because it's more heart friendly. You develop more capillaries, you develop better blood flow because this type of activity encourages capillary proliferation, encourages smaller muscle diameters to have more diffusion. So it's better on your heart to have this type of muscle throughout your body. On the other end of the spectrum, we have high intensity exercises, which typically will condition your body to have more of a reliance on anaerobic glycolysis and less of a reliance on oxidative glycolysis. So you have a decreased oxidative capacity. You can convert some of the fast oxidative fibers to be fast glycolytic fibers. So again, that oxidative to glycolytic conversion because of the type of activity that you're doing. You can decrease the number and size of mitochondria. You can increase the fiber diameter. So again, this is why bodybuilders physically get bigger as they lift heavier weights because it's a higher intensity exercise and it will condition your muscles to just physically be bigger, fiber diameters to be bigger. And then there's a reduced resistance to fatigue. So your muscles are going to fatigue quicker because they're more reliant on anaerobic glycolysis. They have more lactic acid buildup, and they are just bigger muscles, right? Bulkier muscles. So again, this is the type of conditioning that you'll see if you have lots of this type of activity. And it's not just bodybuilding sprinters, right? They get really powerful sized glutes, right? Because the muscles in their glutes are so used to being under that condition, as well as their hamstrings, quads, etc. Okay. And again, just to reiterate here, this is not the most ideal for your heart because there's a decrease in the number of capillaries, decrease in the number of mitochondria, and mitochondria are not just needed for muscle contraction. So that's not an ideal scenario. There's also just larger muscles and they're generating powerful contractions. So when they do that, they can actually compress the blood supply to tissues in the area as well. So it's not the most ideal for your heart. And so we typically advise patients towards more aerobic in terms of overall heart health. Okay, now we can talk about disuse atrophy as well. And this is basically loss in the size of the muscle because the muscle is not being utilized. And this can be seen if there's muscular dystrophy disorders like Guillain-Barré, for example, Lou Gehrig's disease, the different types of disorders where your neuromuscular junction isn't acting appropriately, the neurons are not firing appropriately, and so the muscle is not going to receive the innervation. And so with those types of neuromuscular disorders, you typically see the muscle get really small or atrophy in size. And the reason for that is because we lose the myofibrils. So the myofibrils, which are inside the muscle fiber, and remember, those are the repeating units that have the cross-bridge cycles on them. So if we lose those myofibrils, we lose essentially sarcomeres, we lose the cross-bridge cycling, and we simply make the muscle much smaller and also weaker in terms of its ability to contract.